We are on chapter 14, lesson, and we are modeling today. So I've got a spinner because this is going to help us do some visualizations of what they're talking about here. And it says an angle is a geometric when two rays have the same endpoint. So our rays extend out in one direction, and you can see where they meet, it forms an angle, and that is the endpoint for both of these. So angles are measured by the amount of rotation or turning from one ray to another. So here's my spinner, and I just wanted to give you a little bit of a visual example here. It shows a quarter turn. So here I've got the purple on the pointer there, and if I were to rotate this a quarter turn, I'm not on purple anymore. The purple has moved a quarter turn around the circle. So that's what they mean. If I were to show from where it started to where it is now, probably more like that. That looks a little bit better. That would be a quarter rotation, and that would be a 90-degree angle. So that's what it's talking about with the angle measurements. If we're going from one color and that color is moving a quarter of the way around the full circle, that's a quarter turn, and that would be a 90-degree angle. Now if I were to take the purple from where it's starting at the pointer halfway around the circle, so it's going to be opposite. Now it's all the way over here. That is a half a turn, and that's what we call a straight angle. That would be a 180-degree angle straight across. So we've got a quarter turn, which would put the purple from here to a quarter way around the circle, and then we've got a half turn, which would take the purple halfway around the circle so that it's on the other end opposite the pointer. The last we have is a full turn, and that would obviously be if you're pointing, the purple is pointing this way, it would come all the way around the circle and back to where it started. That would be a full turn, and that's a 360-degree angle because there's 360 degrees in a full circle. So hopefully that helps you visualize. If we were in class, I'd have you stand up and show me a quarter turn and then back, and then a half a turn and then back. So this is a good get up and move kind of activity. You can stand up and practice. What am I looking at when I make a quarter of a turn? What am I looking at when I make a turn around to face the opposite direction? That's a half a turn. And if I wanted to do a complete spin around, I'd be facing back where I was when I started. So that's this quarter turn, half turn, and full turn that it's talking about when we're measuring the angles there. Okay, so I set up on my whiteboard another example of a way that you can think of these angles. I just drew a circle. I used a dish, and I labeled it like a clock. So 12 o'clock is at the straight up top, and opposite that at the bottom is 6 o'clock. And then to the far right hand side I put 3, and over here I have a 9. And that's just the some of the hours on the clock. I didn't fill all of them in because this is mostly what we'll be dealing with. So then I'm going to put a dot in the center because that would be the end point of my rays. And then on Example 1 here, it says trace the lines to draw an angle that measures a quarter turn. So if I were to start from straight 12 o'clock and then I were to go a quarter of a turn around this circle, a quarter of a turn would put me at this 3 o'clock. So just like if we were drawing a circle for our fractions, if we were to divide this up into fourths, 1/4 would be this section here. So 1/4 turn would be straight out like that. So just like this is a quarter of the full circle, this is a quarter of a turn if a complete turn is all the way around the circle. So hopefully that makes sense for you. And that's how we draw a quarter turn, like it's asking us to do. Draw an angle that measures a quarter turn. So they're asking you to trace these lines. Please do that on your book. The two rays form an angle. The center of the circle is the same point as the end point. So this is not only the center, it's the end point. That's what that's saying. And as it said, this is a quarter of a turn. Now, if we needed to draw an angle that is less, as it's asking in number 2, an angle that measures less than a quarter of a turn, I'm going to make something that is slightly shorter than this. So I'm going to erase my quarter turn, and I'm going to make something smaller. So if you were looking at a real clock, you would see 1 and 2 in here. So I could make it anything, anywhere in here, as long as it does not reach this right angle that would be straight out, that would make the quarter circle there. So any of these rays that you see are reasonable for what they've, for the directions they've given on number 2. Anything is less than that quarter turn. Hopefully that will help you. You can choose one of those to do your own. For example, number 2 that's shown there. Okay, so now I've gone on to page 888, and it has the same. We've got a quarter turn, which would be shown like that, and that's what's showing on the picture right here. And you can trace those lines on yours. Then it asks to trace, and this is our end point. The angle you drew measures a quarter turn. Draw an angle greater than a quarter turn. So before we did ones inside that would be less. Now we have to make one that is greater. So anything between the 3 and the 6 is going to be greater than a quarter turn. So anything here would be appropriate for answering the second question on this page. You can choose one of those lines as long as it doesn't go directly out to where the 3 would be, because it has to be down in this second section of my chart. Hopefully that helps you with that one.